Hi, welcome to this Open Security Summit session in March 2022. We're joined by Martin, who's going to present on a super critical topic that we still don't have a good solution for it. As Martin just said, he's not going to present the final solution because I don't think nobody has it, but it's definitely going in the right direction. It's definitely an area that I would love to see a lot more collaboration sessions and ways to figure out how to really make this scale and how to really allow us to have diagrams and threat models and maps and an understanding of reality versus what somebody thinks reality actually looks like. So over to you, Martin.
Thank you very much, Dennis. So first of all, thank you. Hello, everyone. Thanks for joining this session. We're going to talk about creating architecture diagrams as code, but also how to connect those with security requirements that are also connected using code. First of all, thanks to all the team that have helped us prepare this talk, to the team behind the OpenSec Summit, to Dennis, of course, to Alona, to Katie, to everyone, and of course, thanks to all the sponsors because they make this possible. So thanks. There will also be some time at the end of the talk, probably to discuss questions. So if you can save those for the end, that will probably be more helpful. It will be around like 45 to 50 minutes, depending on how long I talk. So yeah, let's start. So who am I? Probably you don't know me, most of you. I'm Martin Obiols. I work for BBVA. It's a Spanish bank with a presence in more than 12 countries. I specialize myself in application security and software security development lifecycle. But you know, in late years I just moved into management ladder, so probably I'm not as strong in that regard anymore. I just believe I do. I'm actually pretty active on Twitter, so there's my handle. So if you want to chat a little bit about these topics or anything related to cybersecurity, I'm pretty active there. And because I'm active there, that's the reason because I ended up here giving this talk, because I chimed into some discussion from an earlier summit where Dennis was talking about threat modeling diagrams as code. And well, I remember that we were actually like 3 years ago or 2 years ago working on something related to that in BBVA. And I started sharing some thoughts on one of the shortcomings of doing that, and one thing led to another, and well, I ended up signing myself for sharing this topic with you guys. As I said earlier, I'm not talking about. I will not present a final solution, but I will probably provide you some inspiration and sparkling some ideas, because learning from the things that we find that didn't work is probably useful to all the people that are trying to solve this complex problem in cybersecurity and in projects in general. Okay, so what are we going to see today? We are going to explain 4 things mainly. First, we are going to talk about the need of trying to improve how we work in security, specifically how our security teams work writing security requirements, and in the end, with these security requirements, drawing architecture diagrams for those requirements. We will do then a deep dive into some framework that we built to manage and automate those requirements as code using regular text files. The reasons why we failed, because we failed, that this wasn't something that stuck with us in our internal processes, but lessons were learned, and in the end, we will present also how we work now, the old way of doing things, but improve with additional tools, and old-fashioned way of doing things, but improve, and probably some key messages that everybody needs to keep in mind, so they don't get too excited with the whole thing of trying to do everything as code, because there are certain shortcomings that needs to be taken into consideration. So without further ado, let's start. The need. Why are we trying to do this to begin with? So at BBVA, on our engineering team, our leadership has provided us with a mission in the form of 5 genes. But you can check that in this slide. But essentially, when we talk about efficiency and productivity and security and control, our leaders are asking us to precisely trying to improve the everyday work that we do as security teams, as security architects, and as security engineers. We need to try to improve that. But there is more beyond that, okay? Because in essence, at PBA, whenever we try to, when an idea is turned into a project or product in production, there are certain phases before that happens that at some point requires some analysis and some design. People start drawing things on whiteboards, getting together to draw on paper, doing some sketches. And the process ultimately needs to generate some blueprint, which we call architecture solution model. And part of that architecture solution model is something that we call a security model. Okay, so this security model is essentially an old-fashioned document, as you can see there. It has diagrams, it has a lot of prose, a lot of words, and we put there every single requirement and description that is important for a technical lead from a security perspective. And this is handled in an old-fashioned Google Docs or Microsoft Word, on PDFs or whatever. Okay, so this is a collaborative effort between several teams. This is not something that only the security team does or implements. This is a document that is collaborative, and I want to emphasize the objective of being collaborative between the security architect, the solution architect, but also the technical lead, which is our connection with the business and with other less technical teams that need to be on board for all the decisions that are made, okay? And they imply features, they imply business and processes, okay? So this is a collaboration effort, but so given that this is the task that we have at hand, this is the task that we need to efficient and to automate according to our engineering genes. So why do we need to actually make that process more efficient? What parts need to be made more efficient, and how are we going to do it? Okay, so let's start with the why. I'm not discovering anything to anyone by saying the scaling up security teams is hard. It will never happen. If you start getting bigger, you get your security team bigger, probably chances are that the company will be getting bigger with you. So essentially, you will not be able to catch up ever. Okay, so you need to start putting efforts into automation, into more efficient procedures, and more efficient generation of your deliverables. Okay, in this case, the so-called security model, okay? Because of that, we started thinking that maybe we needed to reduce pen and paper methods. Traditional methods maybe were not as good for efficientation or to make more efficient the way things were working, okay? Because software speaks code, so why our security models should not speak code too, okay? So that was one of our starting points, okay? This is an important one. The process of writing this security model was like cooking, in the sense that if you have two cooks, the final result of their work probably is going to differ because not two cooks are equal. And this applies to security architects and people that are reviewing projects for security requirements. Essentially, it heavily depends on who is actually doing it. So we wanted that to change, to make the process more homogeneous, more fixed and more standardized for the different people. So it wouldn't matter if the security model was made by a very experienced security architect or by a just new hire, which was bringing some knowledge from the outside. Okay, and also to put the talent where it matters. If you have a process that is open, that is automatable, people that are good at automating things, that are good at improving things, will not just use the process, they will try to improve it. Unfortunately, improving pen and paper methods, they can only be improved so much. So trying to move that into the direction of regular plain text files, code, and automated tools improve our opportunity to employ talent to automate this process even better. Okay. So what do we need? We need something that is scalable, as I was saying earlier, because security teams don't scale. We need something that is automatable to manage this knowledge that ends up in diagrams and ends up in documentation as code. So the regular tools that we know and love, such as software development tools, become useful to automate these sort of things. Okay, we standardize the methodology because we eliminate in that way the problem of the two cooks. Okay, because more or less people will try to deliver the same things because they are using the same tools and they are assisted by them. And everything is distributed and open. So all of a sudden, other people outside the security team are able to contribute to the security requirements. They are able to contribute to the diagrams, just the way that you contribute to other things in the house. For example, documentation or even software code. Okay. So how are we going to do that? Our approach is an open approach. We will create a single point of truth repository that is easy to contribute, as we were saying earlier. We will manage everything as code. Everything from diagrams to security requirements will be regular text files. This is an important thing because we want to ditch old-fashioned Office formats such as Google Docs or Microsoft Office. We will need to create a simple taxonomy, which we will explore later. It will need to also to be extensible because fixed taxonomies are hard to accommodate to the different types of projects and of diagrams that may come up in a big company, depending on the products and on different platforms. And everything will be tool assisted by regular tools such as Git, Visual Code Editor, .language, and general command line interfaces. Okay, so that was what we had in mind when we started this journey. Okay. In a nutshell, we are trying to accomplish this in meme language. A pipeline project is too big to scale, so we are trying to help security architects manually writing these security requirements documents and drawing diagrams and things like that. Okay. So how do we, or better said, how did we do that or attempted to do that? We built up a framework, an MVP for that framework, which essentially did three things. First thing, it enabled us to write architecture diagrams as code. We will, in a minute, see how we did that. Okay. But also not only diagrams, but also security requirements, which tend to be paragraphs or documents by themselves. We try to manage those as code by creating libraries. Okay, libraries in the pure sense of the word from a software development perspective, software libraries. The second phase was to be able to compile the resulting project. So the same way that you compile a program, we will compile the project to automatically generate, instead of a binary, we will generate a document containing all the security requirements and a diagram for this project, for different parts of the architecture and of the elements that are involved in this project. And last, but not less important, we will manage changes in security requirements because this will happen. We will have changes as time passes. Some security requirements will change, and we will manage those as dependency updates. This means we will be able to recompile the projects that we created earlier and to detect changes in security requirements, to notify automatically project owners, technical leads. So, everything is more automated and managed in a better fashion than with old-fashioned document libraries stored on a folder, right? So in order to do that, to do these three things, we build something that is called Sarlacc. Okay, you can see there that this is an acronym for Security Architecture Requirements Lineup as Code. I know it's a horrible acronym, but it's also very hard to come up with good names today because everything seems already picked by everybody. Okay, so don't be too harsh with us in terms of the name we picked. It's not really important. We're just creating an ugly logo for it because it's also the name of a Star Wars universe creature. But yeah, it's just a matter of sharing with you the name, but it's not very important. Okay. At this moment, we are going to do a deep dive into this framework. Up until now, I was sharing with you what we wanted to do, why we wanted to do it, why there was some purpose into why doing this, and the basic thing that we wanted to do with these three things, the write code, compile the project, and be able to notify past projects of updates in the security requirements and diagrams. So let's deep dive into how this framework enables to enable us to do these things. So in a nutshell, the basic concept behind Sarlacc, behind the framework we wrote, is this process. Okay, is this we start with an architecture. We need to translate that architecture, helping with the help of a taxonomy, into a graph, and that graph will be managed with certain tools as code with regular text files. Okay, so let's try to piece this problem into smaller problems and start with translating general and generic architectures using a taxonomy into graphs. Okay, so the taxonomy we came up with is this one. It's composed of 6 elements. You can see there. Only these 6 elements. It's obviously extensible, but we believe that these 6 elements were enough to describe any single architecture that you can think of. Okay, these 6 elements can be classified into 2 groups, which you can see here. Let's start on the left of this slide. Let's start with what is called the graph components. These graph components, composed of elements, interactions, and environments, are essentially the things that get drawn on an architecture diagram. So whenever you draw an architecture on a whiteboard or whatever, these things tend to be visible on this diagram. Okay, so we have, for example, elements, which will be everything that we tend to draw as boxes, for example, on a diagram. That could be applications, that could be users, middlewares, databases, whatever. Then we will have environments. Environments are typically boxes that contain other boxes. So there are some architecture diagrams that need to incorporate bigger elements into containing smaller elements. So this is what we call environments. It will be, for example, an internal network, AWS platform or third-party platform, or maybe a bigger component, a bigger element just that needs to have internal elements, okay, in the diagram. And finally, we have interactions. Interactions are basically where we usually draw as arrows or lines between boxes, okay? To represent connections or interactions between boxes and between elements, we use this, which essentially will be, for example, HTTPS connections, put requests, JDBC connections to a database or whatever, okay? Following up with the other part of the taxonomy, we have the component properties on the right. These are not drawn on diagrams. These are invisible. At the very most, it would be tags or small pieces of text that you put on the diagram. Okay, we decided to classify these undrawn components as on three different components: assets, feature, and attributes. There could be more, there could be less. We could only have, for example, a single component to cover all the possible properties. But we felt at the time that these 3 groups more or less were granular enough to describe all the different things that may become important from a threat modeling perspective or from a security requirements perspective on a diagram. Okay, so it's important for us to describe the assets. Okay, for example, the type of information that applies to one of the components of the diagram. It's interesting to have also features that may be related to some interaction, to some connection, or to some specific platform. And in case that we need just to provide generic properties to one component of our taxonomy, we use the attribute. But as I was saying earlier, these are not fixed. These are more open because these are not drawn. So it's more flexible to use this. But these are the three types that we came up with. Okay. So how do we turn this taxonomy into a graph? Okay, we will make use of the dot language. Dot language uses by tools such as Graphviz to generate from text files, diagrams, and graphs. Is an example. You can see an example right there in this screenshot. So focusing on the left side of the taxonomy, environment, interaction, element, we will be declaring those elements on a text file, as you see on the screenshot, and this will automatically generate a diagram such as the one you see on the right, which is more or less the representation that is registered as text on the left. Okay, so that would be for the part related to the parts of our taxonomy that are actually drawn, as I was saying earlier. Okay, what happens with the ones that are not drawn? How do we register those on the same text file? Because we don't want to manage different formats. We need to have everything on a single file. Okay, so in order to register those component properties, the asset, the features, or the attributes, we will make use of attributes in the dot language. So the dot language allows you to provide attributes to the different components. They have a dictionary, a library of syntax of attributes that affect the output diagram. For example, in terms of the style, the color, of things like that. But the good thing about the dot language is that it's not very strict. It allows you to create arbitrary attributes, so you can put there whatever name you want, even if the compiler does not recognize it, it will just ignore it, and the compilation will still work. So this is in some sense extensible, so you can put on the same file that will later be compiled into the graph anything you want, as long as you conform to the syntax that the dot language imposes. Okay, so that's the way we put this other side, this other half of the taxonomy, the asset, feature, and attributes, into the dot file. Okay, so taking for a moment a step aside, is dot language suitable for this task? So I know there's been recently a lot of discussion about open source projects, the maintainers that are keeping these projects alive. So back in the day when we decided to use GraphBiz and dot language, we also did a check to see the health of this project, and well, the public license that to check that if this was something that we could use in a big corporation. Don't pay too much attention to that numbers, that figures, because at least what this tells us is that this tool is alive and is very well maintained. So it's a good decision. It's good enough for us to use it, at least for starters. Okay. There was some concerns that this tool was not very pretty. Okay, that the diagrams that were generated were in fact ugly. Okay. Reading a little bit about the documentation, the possibility of making diagrams a little bit prettier is there. You just have to put some effort into it to read the documentation. There is a lot of potential with this language to create good diagrams, and they probably compensate for the possibility of being very automatable and handled by regular text files. And we've seen people creating very complex diagrams, magnificent things such as the ones you see on the screen, which tells us that this language is pretty scalable, and you can make it pretty enough for the architecture diagrams. Okay, so how do we create our full example to work with? So let's say we want to create an architecture diagram of some application. So we start with an empty digraph in the dot language. We create these two bubbles representing a customer and a mobile application. Then we start drawing interactions between them. So for example, connections, or in the thread modeling sense, trust boundaries, for example, and we start representing those arrows in the text with that easy syntax that the language provides us. So far, so good, nothing very complex. Then we can make use of the subgraph opportunities that the dot language gives us to create environments, to place some of the elements we just created inside other elements to better represent the architecture. And little by little, we create more complex diagrams, and we arrive to this full example, which is basically a mobile application, which is connecting to an API in AWS that is running on an EC2 instance and connecting to a database. Okay, which essentially will have the look of these two screenshots in text. Okay, so that's good so far. We have already our diagram as code. It's not extremely pretty, but we generated that with just plain text. We can write it, and it's easy to manage with standard software development tools. Okay, we have already created the architecture diagram. So how about the security requirements? I was talking from the beginning, but our objective was not only the diagrams, but also the security requirements. So in order to manage those as code too, we will make use of just Markdown format, which is pretty straightforward. Instead of using Office docs or Office documents, we will use regular text files in Markdown format, which essentially provides us with all the rich text features that we probably need. We don't need any fancy features for this sort of documentation. Okay, so we can embed images, bullets, lists, basic format, which is more than enough to write this sort of documents. Okay. All right, so we have architecture diagrams as code, we have security requirements as code. Now the problem, how do we connect those? How do we make this dot file in regular plain text file to connect to our security requirements in Markdown? How do we do that? So this is the magic. This is where the magic happens. We leverage the concept of the imports for other programming languages. For example, you have here a Java example. When you are writing software, when you are writing code, if you need to connect your code with other code, what do? You import packages, you import libraries. So why don't we do that for our security requirements library? And following this concept, we created the concept of security requirements module, which is essentially a way of packaging small pieces of security requirements into a class path style namespace that can later be imported in our diagram as requirements for a specific component. So as you can see here, we put this Markdown documentation under a specific folder path that will resemble a class path style. And later in our code, if we want to import that security requirements and associate them to our component in the graph, we will make use of this import statement that, as I was saying earlier, the compiler will let us do because it will essentially ignore it and import that component, that security requirements module associated to that component. Okay, in case we need to import several ones of them, we will just put a semicolon between them. Okay. So for our previous full example, for the mobile application, we can, for example, import security requirements for mobile applications written in Android that are actually written in Java, that are using a specific framework of the house, that are actually using or handling in some way personal identifiable information, and that features a login based on FIDO. Okay, and we can import that in our previous text file for the diagram using this construction. For interactions, the same thing. Think about the specific HTTPS requirements that may be needed for a connection between the mobile application and the API. We put that there and we specify the security requirements in the corresponding Markdown file. Okay. The same for the AWS environment, making use of the Sarlacc import keyword and the same class path style interface. Okay. So in the end, we will have some a file structure, a file tree of different folders, and we will put there the different Markdown files related to these small snippets of security requirements related to each of these components from a generic form. Okay. All right. So we have this structure, and then we thought, okay, so how do we connect some security requirements modules with each other? So imagine that you import one of them and these security requirements need to import another one, and there is some chain in that regard. And this allows us to import more security requirements. So then we came up with the concept of security requirements inheritance, which is essentially a help tool to help people using this process to auto-import security requirements module in case they exist, and to prevent the human that is writing this process to forget about some security requirements modules that are actually on the library. because there are some dependencies between them, and everything gets imported in the end. Okay. And this also enables us to write very specific security requirements models that only apply to a very narrow set of circumstances, and that will only get imported for these particular cases. But in order to do that, we need to guarantee that this will be imported accordingly. Okay. So we came up with 3 types of inheritance: based on parent, based on module, and based on self. Okay. The parent is pretty straightforward. The parent is basically that depending on the environment where the component lives, there will be specific requirements related to that component in that environment. So if we have a PostgreSQL database on an AWS environment, there could be specific security requirements for that database and that environment. So essentially, writing the first thing is the same as writing the second thing, where we auto-include an additional security requirements module that, following the file path, will have a specific Markdown file under the PostgreSQL SRM to provide these specific requirements. Okay, and that would be the parent one. The module is basically going forward the class path hierarchy. Okay, to try to import, for example, in this case, if you have an Android application, you will be importing security requirements not only for the Android application, but for mobile applications in general. You can think that mobile applications, regardless of being Android or iOS, will have a common set of security requirements, for example, related to publication or to lifecycle, whatever. Okay, so in this way, we can also import those accordingly. And the last type of inheritance, the self-inheritance, which is a little bit more complex, but essentially generate combinations of the different security requirements module and tries to search for a specific, more specific security requirements module that happen to live below the ones that are already imported. As you can see the picture, we have 2 of them, and the combination of those generate a total of 4 possible security requirement modules that, in case they exist, they will be imported. Okay. So, all right. So we have connected the architecture diagram with the security requirements, and we are managing everything as code using Git, command line interfaces, and general software development tools. Okay. So far. So what do we do with that? We compile projects. Okay. So first of all, we create a project. This is an example of where we put the graph.file, which essentially represents the diagram, and a custom Markdown file with project description and general guidelines that need to be explained for that particular project. And what we do is actually make use of a command line interface that we created, which is basically a script, to help the person doing this process, creating projects, creating modules, to generate the scaffolding for each of these modules of these projects with the default files and templates. Also to the compile actions to generate the automation, and other potential useful features such as the helper to refactor module, to check for module updates, or to update modules. Okay. So essentially, if we have this scaffolding for this project where the security architect wrote both an architecture diagram and a custom Markdown with the project description, we will compile this project and will generate a report and a copy of all the security requirement modules that were used to stitch together that report, right? This will be an example, a general example of something we tried. This is an internal project. This is the look of an architecture diagram of a real application that we have inside in-house. This will be the look of a report, a generated report. It's more or less empty, but we were just at this point validating the solution. One of the advantages of this is that once you generate this, all the security requirements are very closely packed into the different components. So if different teams manage different components on a big architecture, it will be easier for them to open this document and go to the part that they manage and get a better understanding of the security requirements that apply to them. So they don't have to read the whole document from beginning to end. It will be quicker for them to reference and to check what applies to them. Okay, and it will be easier to search, and well, all the all the other advantages that we mentioned earlier. All right, this looks good, but as I was saying earlier, this wasn't so successful. So why we fail? Let's share with some of the conclusions of trying to use this in the wild. Okay. So the first reason why this didn't work, or this didn't turn out so good, is Git is terrible for collaborative writing. And let me explain, because maybe you are thinking Git is a collaborative tool. Why do you say that it's terrible for collaborative writing? So Git is great for having a lot of people managing a lot of files in a collaborative fashion and managing conflicts between them, and in general as a source code and software development tool. But it's terrible for collaborative writing in terms of documentation, particularly when several people are trying to edit the same file. Same file concurrent edits almost always are going to generate merge conflicts. And the problem is that these merge conflicts will not be visible to the people writing them up until the merge happens. Okay, so people tend to open a branch to start working, and maybe a day or two pass by, they have written a paragraph or two, they try to merge, and then the conflict happens. And the problem here is that you need to picture as if you had two software developers writing the same Java method of the same class at the very same time. Chances are that when that merge happens, they will have to choose between one of the commits or the other one. It will be very hard to mix and match those. So in the end, it creates frustration to the teams, and favors that people don't get so collaborative, because start working on something and then sort of locked that part of the document, so they are the only ones working on it, so the merge doesn't happen. And what that's essentially one of the feedback that we got from the teams trying to implement this, that Git wasn't that good for collaborative writing. Okay. The second one is that reports, unfortunately, the security models, that the automated document that we create, will always need manual edits. Always. It's very hard to generate automated documentation by stitching together different parts, because natural language paragraphs, when stitched together, unfortunately, will generate documents that are not very homogeneous and that don't look like a proper document. So inevitably, people will tend to try to edit the output result of the compilation, and any customization that will be made, any edits, any manual writing that will happen after the compilation will essentially be lost. Will be lost on next compilation, because will be overwritten, because the tools will not be aware of whatever you try to write, and it will not be efficient to try to edit that on the single repository where it came from, because that won't be reusable enough, okay, for our project. Okay. Also, coming up with the right taxonomy structure at first try is impossible. It will generate modifications on the taxonomy. What is initially considered an element will be turned into an environment later, because the box will start containing other boxes. So essentially, this brings us to the third reason we fail, is that library refactors will break existing reports. So these taxonomy choices that we make, choosing something to be an element or choosing something to be an environment, will essentially create conflicts in the future when we change those, because renaming one of these security requirements module will break existing project compilations. So essentially, if you created a security model a year ago, the compilation of it will probably break, and you are making people, forcing people to take care of past documentation more than they were doing before, okay? Because they need to go back to that documentation, fix the compilation, and it may become not very easy to do in a hurry, okay? Also, we need a way to prevent that from happening, and to make the sticky versions of security modules, which essentially kills the whole purpose of this, okay? Because if you fix the versions of the security requirements module, we lose the opportunity to make automatic updates and to notify users of changes in security requirements and so forth. Okay. The fourth point that we discovered, diagrams might become too complex for text. The full example that we presented was already a little bit daunting at first sight. Imagine more complex architecture diagrams. We tried to do one of those, and the text file was very big. And for the person that actually wrote it, it was easy to locate the exact part where an edit needed to be done. But in the end, diagrams, unfortunately, we believe need a what you see is what you get editor. That's just the way things should be for visual things. Okay. And unfortunately, today, what you see is what you get editors, and code auto generation won't mix well because you don't own the code that gets generated after you use a visual editor. So it's hard to go after creating something visually and grabbing that text file and trying to do things with that, because you don't own that. You don't own that. Probably would be changes in ways you don't anticipate. So yeah, and this we will see probably some improvements in that regard whenever the so-called no-code platforms start to get more popular, probably. Okay, and lastly, and this is actually very important, unfortunately, or maybe fortunately, most people prefer working with Google Docs or Microsoft Office formats. VS Code or IDEs or Beam or whatever are not quite friendly for collaborative document writing. They don't provide ways of having comments on the margin, of putting comments or highlighting things for other people. So it's not very collaborative in the end. Also, not all security architects are very proficient with Git. They may be nerds, but they may not like trying to write things in regular text files. Just the way it is. And we had also some feedback in that regard. And they also don't enjoy using command line interfaces. Okay, so there's a reason there is so much effort put into Google Docs and visual things, because the amount of effort into ramping up knowledge to use them is probably smaller than using command line interfaces. Okay. So how do we work now? So we went back to the old way of doing things, but we actually had some improvements since we started this. Okay, so we started doing diagrams using what you see is what you get editor based on Draw.io. Okay, as you can see there. What we did in order to bolster efficiency and collaboration and automation and reusability is to actually create libraries of components, of internal components of our architecture that help us speak the same language, draw diagrams faster, and give everything a sense of homogeneous output, and so everybody's working on the same things. Okay. Of course, this doesn't bridge the gap between having the visual diagram and the security requirements that come later, but at least it's a starting point. Okay. Unfortunately, these diagrams work with XML files, and as I was telling earlier, owning that format is not recommended, because trying to do crazy things such as the ones we were trying on the dot language with that XML file, we were not very fond of attempting that. Okay, because it seemed like not very wise to do that. Okay, but what we did is in order to bridge the gap between these components that are drawn and the security requirements, we started working on libraries, old-fashioned libraries on a site with design blocks, design patterns, functional features that are associated to each of the components that get drawn on the other two. And with careful versioning and with an open approach, everybody can go into this site and check the latest version of this component and get on board and get on speed on what will be needed in order to deploy this particular piece of the whole diagram. Okay, so that have been an improvement, and we will have to double down on this approach because it's giving very good results. Okay, we are also encouraging people to use tools such as swimlanes.io, which is a free tool that is online and that allows you to create swim lanes diagrams such as the one that you're seeing, but creating those with text with a syntax more or less similar, but more simple than the one from the Dot language, as you can see on the sample. But the thing is that this is extremely fast and extremely easy, and you can create very, very good diagrams that are very important to represent the different interactions between systems. So the first diagram that we show here are good to get a hold of the general picture of an architecture, but in order to understand the interactions between different systems, we believe that swim lanes are a better tool. And well, since drawing these sort of diagrams can be a little bit cumbersome, because you know, if in case you need to change something, everything needs to be moved below to make room for the new arrow that you wanted to draw. We found that, you know, using this tool was making life easier for people writing or drawing these diagrams. Okay, and these diagrams are actually great to represent interactions between systems. Okay, so that's something that we are making extensible use now. So to wrap up, after, you know, our lessons learned, some conclusions. I was browsing some days ago the yellow site, Hacker News, the orange site, sorry, Hacker News, and I saw this post referenced, which was write plain text files. So essentially, this was someone on their blog post, you know, talking about all the advantages and the things that improve the way you manage your knowledge if you use just plain text. And there are certainly some comments that both this approach and explain why this was a good idea. Okay, another advantage is to plain text files, source control. Yeah, we talk about that today, which is probably an easier thing, because it automatically encourages you to take version control of things, and you don't end up doing, you know, the final report draft docx. Okay, which is something that every single one of us has done at some point. Okay, so yeah, the man has a point here, but there was also some comments that are basically well, some of the things that I just mentioned at the end. Modern office formats are still good. Putting things on wikis, on old-fashioned documents have improved a long way in late years. We have a very good set of office tools today that encourage collaborative editing, notifications, rich text formats, and in general, I think we have come far enough not to ditch these formats right away. So in the process of trying to automate things and to making things more open and more collaborative, let's not ditch these formats to begin with, because trying to make everything plain text, the same way that making diagrams pure text files can be daunting once your diagram is complex enough and you start to be on the dire need of what you see is what you get editor. That happens too with documents. Okay, and you know, there's a reason these office formats are used by everybody. So at least give it a second try, and you know, focus more on the processes and on the way that, you know, the whole process of building things connects together. Put the text files when they can actually improve things, and try to automate everything that you need, but don't get too carried away with reaching these sort of formats, because probably we are still too young or too immature to actually replace those with regular Markdown or things like that. Okay, so yeah, that could be it. Thank you very much. I really enjoy failure stories when I watch to conferences. Hopefully you enjoy this story too. Hopefully this will spark some inspiration to all of you that are working on trying to create diagrams as code and to automating those things. And as I said earlier, you can hit me out on Twitter, and if you have any questions, feel free to ask them now. Cheers.
There's some question. Hello, Martin. Thank you for that. There's some question in the chat. You can just check on them.
Yeah, okay. Let me check. Hi, Martin. I have two questions. How do you manage if you're required to show your diagrams to a business stakeholder? They don't understand technical components. Okay. Yeah, so as I was saying earlier, this security model usually is more technical documentation that we write. We have another sort of diagrams that we build that are called functional maps or functional diagrams. The solutions architects usually draw those and are basically composed of functional boxes, and these are more easy to understand for a business person. Okay, they don't usually get to take a look at our technical diagrams because, as you said, they are not very friendly for them. But essentially, if some business person is actually able to understand those, you will have in the end a general architecture diagram drawn. You will not show to them a dot file, obviously. So you will have to show them the final compile graph, and hopefully, depending on the amount of effort that you put into making it pretty, probably it will be understandable to them. Okay. And the second question was, how do you evaluate if all the security components requirements are in place? Do you have a test solution or the responsible must review the final format by hand? Yeah. So imagine in the old life, just of writing documents, this was done by peer review. Okay, just by checking with a colleague or by other people that may check your security model and check if you forgot anything. And in order to do a specific technical test to validate those security requirements, that is done on a later phase, okay? On a phase that probably the security requirements is taken as a starting point for the security test, but these are not connected as of yet, okay? So the answer to your question will be, we still believe on peer review. And what we tried with this process was to actually reduce the amount of security requirements that may become forgotten by the security architect by doing this, the thing I was explaining earlier about importing. And
I'm doing well, thank you. How are you?
Very good, very good.
Hello, Dainis. You have the mic open. So,
sorry, I was on another call.
Okay, no worries.
So
yeah.
Another, yeah, we have another question. That's from, I think I sent it to you. You can just check over at the top.
Okay.
Yeah, from David.
From David. Okay, David. PyLatex. Well, first of all, this is not actually published, so so the huge part of the work of this framework is already presented here. It's basically the thought process of the taxonomy and the security requirements module and following the dot syntax. The value of the code that we built is not very much because that was basically a couple of scripts that we were sort of scrapping together to validate the idea. So I don't think there are a lot of value into sharing those into a public GitHub. And well, no, we did not give a look to PyLatex. Probably that would be another potential solution to generating the documentation. But as I mentioned, the problem was not generating the documentation because Markdown is perfectly good for that. The problem was, actually stitching together the different parts of it. Okay. So swim lanes locally, no. As far as I know, it's not possible. I at some point I reached out the author, and he did not provide with any way for that. He just told me that we need to continue using the site. So yeah, unfortunately, swim lanes locally, I'm not aware of any open source solution to compile those locally. Okay. Ruben Maldonado said, thanks for your explanation. Are you thinking of instantiating the solutions designed by integrating it with an infrastructure as code solution or something similar in the future? That was our intention originally, to once we had this working, to be able to connect those somehow with other code that essentially resembles infrastructure or whatever. But no, right now at the moment, this is only something that help us, move in the direction of fostering what you see is what you get editors, and connecting those with small design blocks that get documented on a site. And for now, that's working for us. And there are more opportunities certainly to improve that and to automate and to connect with other parts of the whole life cycle. But as of today, we have not thought of that. Okay. I think I went through all of the questions, if I'm not mistaken.
Thank you so much. Anything else?
I think Petra is trying to say something.
Hi.
Hello, Petra.
Hello. I can't even start video. Host won't let me, but that's okay. I just wanted to say that was a really great effort that you guys tried to do. You know, it's very impressive. I'm trying to do something similar myself. I'm kind of started with Markdown, developing it into JSON files in Jupyter notebooks and Plant UML graphs. So I just have a few questions. I'm just curious, how many people did it take you, and from which teams, to start building this and to build this? Do you think this is viable for smaller teams in smaller companies, or this is kind of better for bigger companies where you need to scale? And have you completely then given up on the idea to have this kind of, you know, security requirements / threat models as code? I mean, also architecture diagrams as code, or do you think it's still viable? Do you think it can still be progressed, but with a different methodology?
Okay, so first of all, amount of people needed for this. So this was a fairly small rate from a very small team. Excuse me. This was maybe we were working on this pilot around 5 to 6 people, but you know the hard part was coming up with the idea, with the taxonomy, and with the concept of the security requirements auto import features. So we were not that big, and the scripting part was maybe like 2 days work at most. So we tried to stitch that together in a very short time. The actual part was, you know, the process of trying to apply that into a real project, coming up with feedback from the people participating in the pilot, you know, looking at the big scheme of things to try to see if we were going into the right directions, because essentially what I shared today was not the first version of it. Okay, the taxonomy was different. We're starting making some progress, and you know, discovering things that we have not thought of before and things like that. Okay, so essentially it's probably something that needs it's more suitable for bigger companies probably, but because this essentially the gains from this are based basically on automation and of the different of the hardships that people suffer on big companies, because new hires, particularly new hires in big companies, have a hard time getting ramped up into everything that is needed to build a security model, understanding all the pieces, connecting them together. So these sort of approaches probably will help them to do that and to ramp up their knowledge quicker for these new hires. Okay, but yeah, essentially, I guess this is something. And have I abandoned this idea? No, but I believe there is the problem also with the proper approach to development of platforms and of architectures. So I believe that the concept of a paper road, of secure defaults, pieces that work secure by default, so people don't have the opportunity of breaking things or misconfiguring things to create unsecure platforms or unsecure architecture should be done. So the most of the effort should be done in that way. So if you create pieces that are secure by default, give them to the teams, and all the products and other platforms are created by default with security by default, all of a sudden the need of specifically writing all the security requirements to all these platforms become less relevant. Okay, and you can focus on the very specific of each project. and these specifics of each project will probably be less reusable, and you don't have to worry that much about reusing them, automating them. So just by making them available, open, having them tidy on a wiki or on a library of properly maintained and referenced, it will be enough probably. Okay. Does that answer your question?
Yes, thank you, Martin. I hope I can maybe even ping you on LinkedIn to see if I can get some advice on what I'm trying to develop, because you know, having some experience with a failed project, I think it's super valuable to kind of have to create something new as well. So
sure, fair enough. All right. I don't think there are more questions.
All right, thank you so much. So any questions? Last minute questions before we're going to end. I'm going to stop the recording.